I'm not on the right page on this. Sorry. Let me go back. Okay, so we're going to be looking at, we're going to be talking about temperature. And the question we're really going to be focusing on is, why does the temperature of a liquid in some cup systems change more than in others? So I have 2 cups, and you know Miss Hill and I love to go to Starbucks every morning. And sometimes she always gets an ice drink. I vary. But when we have our ice drink in this type of just a regular throwaway cup, why is it doesn't stay cold as longer as if I had had more of a fancier cup? I want us to kind of think about that. So what the difference might be here between the two. Yes, even though this one has a Starbucks logo, you know, because I had to have it at one point. But what would keep this colder than in here? So I want you to think about it. Okay, so I'm going to come by. You can look at it as I come by. Yep, we cannot. Okay, so here's my regular cup. Here's the fancier cup. Okay, all right, regular Starbucks cup, right? Fancier cup, right? So right now we're just thinking. Everybody, I see the curiosity in all your faces. Ooh, ah, yes. Yes, see, okay. All right, so right now, I want you to turn to, in your group, I want you to have a discussion. Why does the drink in the regular cup warm up faster than if it were in here? So talk about it with each other. Why do you think? What about the material?
The plastic on the fancy cup is thicker than the plastic on the regular cup.
Okay, so the plastic on the fancier cup is thicker, so because of that, it does what?
It doesn't let as much water out or condensate.
Okay, it doesn't let as much condensation out? Is that what you're trying to say?
Yeah.
Okay, and what's condensation? Does anybody know? I'm just asking. There's no right or wrong here. We're just getting our initial ideas. Okay, so we have an initial thought that the thicker plastic, for whatever reason, is keeping condensation in, yes?
Yeah.
Okay, so that's where we're initially at. Sounds like a good starting place. Thank you. Okay, over here, what did we say?
Okay, one is plastic and the other one isn't. The other, like the copper one is like more thinner, like thin, and the other one is like more thicker.
Okay.
Maybe the.
This is a good thing. One is thinner than the other, okay. Any other thoughts from anybody? What would the thickness have to do with it?
It could like it takes longer for it to melt if it had ice in it, probably.
Why?
Compared to plastic.
I guess it better protects the cold, maybe.
Okay, better protects the cold. What do you mean by that?
Like, since it's a bit thicker, you can keep it cold for longer.
Okay, because it's thicker, it'll keep it cold for longer? Okay. All right, these are good initial thoughts. Good. Great.
Did you say that?
No, I didn't. I mean, every group, I haven't gotten every group, right?
Sunscreen on top of it.
Okay, let's come back up here. Okay, and let's kind of share some ideas. So I'd like to hear from this side of the room because I already know this. Well, they'll show their thinking, but yes, Jade. Okay, somebody else? James, tell us.
We're talking about how the fancy cup keeps stuff colder than the regular cup because of like the material they made it with. They made the regular cup of cheap stuff since it's like meant to be like thrown away.
Okay.
And they made the fancy cup out of more high quality material since it's like meant to last longer.
Okay, and so because there is a high quality material, as you say, in the fancy cup, then that's what keeps it colder than the other one? Okay. All right, these are slightly. Only. Why do you say slightly?
Because plastic, it doesn't hold. It'll hold the temperature. Like,
Yeah.
it doesn't really matter if it was more high quality. It still doesn't like the sun. Like if we're outside, the sun would like reflect still into it and melt the ice.
Okay, so Kendall's saying like it really isn't a big difference between either of the cups, right? That it's still going to melt because it's still see-through, and if it's outside in the sun, they're still going to warm up. Okay, this is a great initial thinking. All right, here, my group here. What do we think?
We thought the same thing. No, we thought it was thick.
Yeah, that's exactly what they said.
The thicker layers, the heat would less heat would enter the cup, and so the inside more coldness will maintain.
Okay, so here's another thinking. He said that the heat doesn't get in as fast, right? Like it's not coming into the thick plastic versus the other one, the heat's coming in faster. Okay, awesome. If I could have attention up here though, because I see a lot of kids drawing in their science notebooks right now, and I'm going to ask that we stop, and this will be the only warning on that. I've already asked you earlier to stop. Thank you. All right. So let's talk about here, let's make a claim here. So based on what everybody is saying, I see that if we put it together, how many groups think the fancier cup's going to keep it colder longer than my regular cup? Raise your hand. So you think the fancier cup keeps it colder longer. Hold them up high. Okay, how many of you think that the regular, just disposable, I could throw it away today, this one keeps it colder longer? Raise your hand high. I see some questionable. Okay, that's all right. If your claim is different, then we want to write that. Majority of us, though, are going to say here that the fancy cup works better than the regular cup. So in your science notebook, I would like you to open to a clean page that does not have anything on it, please. And at the top, you are going to write cold cup test. So let me pull up. Where is it? Sorry. So at the top, if you could write cold cup test, because we're going to be testing it out today. You're going to actually test this out. So at the top, next blank page, write cold cup test while I get the hover cam going here. Okay, hopefully it's coming up here someday today, not tomorrow. It's very slow. Okay, and then I want us to write our claim. Now, your claim may be different than my claim because there were a couple of you that said the regular cup will keep it colder longer. So if that is true, you need to write that as your claim. Most of us, though, said the fancy cup works better than the regular cup. So if we could write our claim down, whichever way you're going to go. And then I want us to start thinking about how can we test this? So how can we test which cup is going to make, keep the drink colder longer?
You can put water in both of them at the same exact time, and then you can keep checking it, and yeah.
How do we check it? How do I know if it's cold still? What do I need to use?
The thermometer.
The thermometer. Okay, so we will create that experiment. We're going to take both types of cups. We're going to put ice in them. We're going to use thermometers. We're going to check back, and we're going to see here kind of which one actually does keep it colder longer. All right, so if I wanted to make a data table Okay, again, I have two types of cups, and actually let me give you your cups here. I'm going to come around with them here. They are the same types of cups, even though some of them have like a different color. They're still the same thing. It's the double layer plastic. Okay, this one just has like a hand on it, but at the bottom it's the same thing. Okay, so let me give those out, and then I'm going to give you a regular cup as well. Put that over there. Don't drink this water though.
Is it bad water?
No, what came out of the paint bucket water. So like it's clean water, but it's the bucket's not clean. So no, don't drink that. Gross. If we could move those Chromebooks so they don't get water on them.
Loud.
What are we playing? Are you playing with the water?
No, he's trying to drink it.
Oh no, don't drink it. Okay, so in front of you, we have two things we're going to test. So we're going to make a data table, okay? And we have to figure out the different times we want to check our data. So let's first copy down our data table here. So we have our regular cup and our fancy cup. Sorry, I'm going to move. Yep, you're drawing your data table because you need a place to record it. If you can't see it, yes, move up. I'm going to come by and drop ice in. One scoop. One hand scoop.
Oh my gosh, look at that. No, you have to put the same amount of ice.
I know, it's a scoop.
Okay.
That fell out of my hand, the other one. I know, it's not. For our purposes today, it will work.
Is the ice
Can I have one?
Yeah, can we have one?
No, I literally just stuck my hand in this ice. Okay. So now we have our, I need to give you your thermometer, sorry. 1, 2, 3, 4. 4 thermometers. Here we go. Thermometer. Okay, on your thermometer. Don't put it in anything yet. Don't put it in the water yet. Let me look up here real quick because I want you to look at the thermometer so you know how to read it appropriately. Real quick. I'm sorry. I'm going to put that back up here in a second. But if you look here, okay, the left side here is going to be our Celsius, okay? So if we're recording it in Celsius, which, you know, we sometimes do. And our right side here is going to be, not our Fahrenheit. We're going to use Celsius today, so we're using the left side. So if we look here, your thermometer should be around 20. Or do we see that? On my left side over here, you guys, Jade. Okay, so we're going to be recording on this left side. So what I'd like you to do is you're going to, this one is going to be after 1 minute. So 1 minute after it's kind of been sitting in there, I'd like you to take the temperature of both. And then I'd like you to record your data. All right, so if we could start doing that, go ahead.
Wait, what? Oh, put it in.
You're going to record your data on the fancy cup versus the non-fancy cup. You have to leave it in there.
So aggressive.
And then I'm going to use a group's data since I don't have a cup myself. Grab a pen. Fancy cup versus regular cup. So if everybody could be taking their temperatures on that.
cup is making 1 degree.
And then I want you to record it on your notebook there.
Did you put it the wrong way?
Yes, you put it in the wrong way. The red part has to go in. I'm sorry. I should have made that more clear for you. Sometimes you just assume, you know. That's what happens when you assume. The bottom part is where it comes from, James. The red. Okay, what do we have here? 1? Oh, 1 degree Celsius. You're not recording your data here. This one. Okay. John, don't forget to record if you haven't. What, did you guys record 1 yet? No, we're still waiting. Are we ready to read it? So read it. Who's going to read it? So you're looking at the one on the left, Celsius. Okay. Record, so remember you're looking on the left side. And then I want you to record the other side. I want you to do the other cup that you haven't tested. What was the second cup? So what was the fancy cup was 3 degrees Celsius and the regular cup was 5? Okay. Okay. What about over here? What was our second measurement here?
Wait, let me see.
10 degrees Celsius. It was almost the same as the regular.
Yeah, but that one didn't move. It didn't move, but you put in the second.
You might need to leave it in a little longer. Oh, they were exactly the same? Okay, great. All right, yeah, I mean, hey. You guys, and what did you guys get? 8, and then fancy cup was 8. What was the regular cup? Okay, we'll switch it over. You guys need to switch it over. So, right, regular cup was 8. Look at the, yeah. Okay, so I'm going to use Ty's group's data just so I can, because they already finished both, just so I can get that. So they said theirs was 5 degrees Celsius on the regular and 3 degrees Celsius on the fancy cup to start. Okay? Well, I mean, that was the first one. So now the question is, when should we retest this? Because I want to point out, Miss Hill drinks her iced coffee literally until lunchtime. Sometimes even at the end of the day, it's still sitting there. So let's think about our testing time, but also in the essence of time, that we don't have a lot of it, right? When should we do our second test? Chloe?
10 minutes.
10? Should we do it a little sooner? 15 is more.
3.
3? 24 hours. We should test tomorrow morning. 5? Okay, so maybe every 5 minutes. Maybe 5 seems more reasonable. All right, so we're going to test every 5 minutes. All right, so let me set a timer. Sir, you set a timer for 5 minutes. Okay, so we are going to check back at this data in 5 minutes. Ty, can you close that door for me, please? All right, let's go back up here, though, because I have more I want us to look at and talk about what we weigh, because we are mating. Wow, that was really delayed. Sorry. Thank you. All right. So, oops, I went too far. Here we go. Now, I want us to think about, because I asked you earlier when I walked around, I asked you to tell me why you thought one cup was going to be better than the other. Okay, and different groups had different reasons. Some were similar, but some were a little different. So I want you to think about, what are the parts of each cup system? Meaning, like, what parts make up this whole cup here? All right, so I want you to think about that first. So just thinking in your head. Okay, and what does each part do in that system? So what is it that each piece in your cup helps it to do? And my last question is, how do the parts work together to keep a drink cold? So right now I want you to think about it. There's 3 questions there. If you forgot my questions, they're right there when you look at them. Think of some kind of answer. Because remember, we're trying to explain why one cup is better than the other, right? So we want to think about why is one better than the other, what's making it be better than the other. All right? And now I want you to turn and talk to your table, share out your answers. If you forgot the questions, again, they're right there on the board. So I'm going to let you discuss it. The what? Well, the whole cup is the system. So, right, what's the purpose of the cup? To hold the liquid and to try to keep it cold, right? Or hot, depending on which one it is, right? So what parts of it are making it do that? All right, so as it together, talk about that. And then I'll come back. All right, what did we come up with?
Oh, we've been arguing about people touching the cups.
Oh, people touching the cups. Don't touch the cup.
Your body heats.
Yes, exactly. Okay. We want to talk about what's making up, why is one cup better than the other?
This one has
But the
multiple
cheap
layers
cup
on
was
it.
just used for holding beverages, or the expensive cup, which has layers. And probably thick.
I know.
Not to mention
Okay, look, the ice is already melted.
Dang, maybe the normal cup.
That is an observation. The ice is already melted in that one.
Maybe Messiah is right.
So why would that be melted faster than that one?
If
It's
it's
because of all the lights.
If it's warmer?
yeah.
So the cup might have already been warmer?
It's because the lights are going into it and it's trapping the heat inside, not only just the food.
Oh, so the heat's getting trapped inside of it and can't, whereas here it's not?
Escape.
Oh, that's interesting. It's an interesting thought. Okay. Okay. All right, what did we talk about here?
Are we supposed to put this back in?
No.
We were talking about
Parts of each cup system. The outer layer and the inner layer.
Okay, what about the outer layer and inner layer?
Outer layer helps keep it cold. It's like protecting
Gravity.
it's protecting the hot air from getting in, and the inner layer is just like a regular cup by itself.
I think this is kind of absorbing the heat, and while this one is like just letting it go in.
Okay, and why? How is this one absorbing the heat then?
Well, you can see that there's kind of like an outer layer and then like an inner layer for like extra protection, but then there's also like space inside of it, so it's kind of like capturing heat maybe.
Oh, okay. So you're saying in between the two layers is where the heat's getting trapped.
Maybe.
Okay. Okay, maybe. That's kind of an interesting observation. I like that. That's good. I mean, this is good thinking, right? I mean, we don't know yet, right? Okay. Thoughts. What do we want to share? Okay, Lila has a thought to share.
Yeah, I you explain it well. Oh, okay.
Explain it your way, and then John can chime in.
In like the fancy cup, there's like it's thicker, right?
Okay.
So like the heat of the lights is like getting trapped in the cup,
Okay, in there, just like this. It's just flowing into the cup.
right? And it can't get out. And like the ice melted. So yeah.
Okay, so their group is pointing out. Ooh, it's 5 minutes. Their group, go ahead and stick a thermometer in one of yours for right now while we're talking. Okay. So their group, listen to their observation. They said that the heat is going into the fancy cup, right? And it's getting stuck in there because it can't exit out. And so their ice melted already in their fancy cup versus their non-fancy cup. Okay, good observation here. Chloe, can you explain what you said to me, to the group, about your double layer cup, your fancy cup?
So I noticed that this fancy cup has 2 layers, like one on the outside, one on the inside, unlike the regular cup. So I thought, okay, maybe it's extra protection. But then I also noticed that there's a thin little opening between those 2 layers, and I thought maybe the heat would get trapped in those, and that would, yeah.
Okay, so she said in the fancy cup there's 2 layers, right? There's an outer one and an inner one, and that there's space between the outer one layer and the inner, and that the heat is going in and getting trapped in between the 2 layers instead of going all the way to the liquid, right? Maybe. She said maybe. we're not sure. Okay, these are two very good kind of different observations that these groups have made. So now what I want you to do, because I know you're still getting your numbers, but as we're getting them, I want us to kind of draw a model. So remember we worked on models in science this year where you drew out what was actually happening or what you think is happening. Sorry. So you're going to, on the left side of your page, and if you don't have room there, do it on the opposite. I really don't care which side it is on for today. You're going to write your cup system model, and you write regular cup, fancy cup. And on there, you're going to draw your cup and show me what is happening. So I heard some interesting things. I heard double layer, heat getting trapped. I heard this group here said, oh, the heat's coming down into the cup and getting trapped. You have to, I want you to draw it and show me and label it on in your notebook. So right now you are drawing both cups. You're drawing your model. You're going to label what do you think is happening. Okay? So X, I already see Abby working. Thank you, Abby. And then as you're doing it, make sure you're getting your numbers too. Or at least one of you is recording numbers. Suri, set a timer for 5 minutes. So I want you to point out into your models what is happening. So I don't want you just to draw a cup. I need to know what is happening to the ice or the water. What is happening to my nice iced coffee? Let me know when all the groups have their data for the 5 minutes, and then we'll do the next one. Did you guys get both numbers or no? Only one so far. Okay, one more? Okay. Okay, and then after you guys record your data, you're going to be drawing your model. So you're going to draw like your cups. So see how she divided her paper. You're going to draw your cup and show me what is happening to the ice and the water. Your cups do not need to be pretty because I know what you mean when there is a cup drawn there. So please don't spend 9 hours drawing a cup. Okay. And if we could actually draw a cup on this table, this would be great. On this side, divided in half. Regular cup, fancy cup, like Lawrence. Okay. So then I want to know what's happening with the ice. Like how come this one has no ice? Where did it go? Well, I need you to tell me why it did or where it did. Okay. So then I need you to label it. Remember, you have to label what's happening in your model. You can't just draw a cup. Okay, great. You know how to draw a cup. Fancy. Love it. But what is actually happening to the fancy cup and the regular cup? You could use arrows, you can use words, you can label it. And if you know what's happening, like what's causing the ice, why is my ice going away? I like when it has lots of ice. I mean, especially if it's like coffee bean iced coffee, they have the best ice ever, right? But why does it disappear? What's causing it to disappear in my liquid? So in your model, I should see something that's causing it to melt and not be there. This. Can you be more specific than this? Okay, I'm going to set the timer again for 5 more minutes. Sorry, set the timer for 5 minutes. And in a minute, I'm going to ask for some volunteers to come up and share their models. For Candy. Yeah, Candy. Candy of your choice. See how many hands go up when you offer candy?
No, I was like.
Oh, you were just ready to go.
Yeah.
Okay. Okay, I'm waiting for, I'm going to give it like 1 more minute. If we could identify on our models. And then as students are sharing, if you see something they're like, oh, that's genius, and you want to include it in your model, you may do so. All right, Lila, since you are so excited to share, can you come up and share your models?
Can I do the fancy cup first?
Yeah, well, I mean, let's see. There, okay, wait, here. Let's zoom in. Okay, I want everyone looking up here. And so here's her fancy cup.
Okay. Wait.
Go ahead.
Okay, so basically, the thickness of the cup is it's trapping the heat in the cup for the ice melt.
I lost my shoe. Sorry.
What else did I say?
Okay, wait. So wait, what happened?
The thickness of the cup traps the heat and the ice melts.
Oh, okay. So, but how do I know, like in your model, I don't know where the heat is coming from. Like where is it? It's just kind of, can we identify that?
Basically.
Can you draw it? Can you draw it? How can you represent that in your model?
Yeah, this is a light. And that's the heat.
Can you label that though? Because right now, I mean, your drawing is beautiful, but in case somebody comes in and is like, what is this? Then they know that there's light. And then what are these like squiggly lines? Oh, those are heat. That's heat rays coming in? Mm-hmm. Okay. All right. And then what's happening to the heat once it gets in there?
It gets trapped. And
how can you show that?
The thickness of the cup.
Well, where's the heat going?
It's in the cup.
Well, how do you show that in the cup? Can you label it? Maybe if you label it.
Okay.
Okay. All right. Could we identify, because it looks like the heat's trapped on the outside.
What?
Like your arrow.
Oh.
There we go. That's a little better. Does that seem that's a little more clear? That she's saying the heat's trapped on the inside so that this light, the light, like this light, that's what you're saying?
Yeah.
Oh, just this light. Okay, this light,
No, like
all light. All light. So all light has heat? Okay. Oh, that's an interesting idea. Okay. Awesome. Do you want to show your regular cup?
No.
Can you show us your regular cup?
Yeah.
Even though I made you draw more on yours.
It's like really
You get 2 pieces of candy.
okay. So basically, since it's thinner, it's like the whole opposite of the fancy cup because like the heat is like able to like leave. Because like I know that because like there's like little droplets like on the outside of the cup, which is like not on the fancy one. Yeah.
Okay, can we draw that? So you're talking about does anyone know what the droplets on the outside of the cup are called? Condensation. Oh, we're going back to the water cycle. Yay, it all revolves back to the water cycle. Your favorite topic of the 6th grade. Bill Nye. I mean, he is wonderful, isn't he? I mean, even though those videos, they're like timeless. Okay, there's condensation on the outside, but where is the heat then? Because you said there's heat. Heat is what's causing this. Where's my heat in this? What you have to represent it in your model. Everybody should be now looking at their own model and thinking, oh, where's my stuff being identified? Okay, good. There's light.
And the heat again.
And the heat. Okay, awesome. Okay, let's give Lila, because she was very brave to come up here, a round of applause. Oh, hey, where's our round of applause? Wake up, wake up. Thank you, Lila. Remind me to give you a candy. All right, I need one more. Go ahead and pick 2. One more, Ben. Well, come on up. I know he only came up for candy, but, you know, we all work for something, you know. Okay. All right, is this fancy or regular cup?
Regular.
Okay, here's his regular cup. Oh, wait, real quick. As he's explaining, somebody test your water for the 3rd time. So just stick the thermometer in. All right, but also listen to Ben. Okay?
The regular
regular cup has no ice because of the heat and it evaporated.
Hold on, guys. Shh.
The heat is coming from the sun and it only has one layer.
Okay. Any questions for Ben about his model?
How's the sun coming in the classroom?
Everywhere.
Oh.
The sun is everywhere? Oh, from the windows. Okay. But it's overcast today. So where is that heat coming from then? Anybody want to help give him some any ideas? Maybe where possible heat? Because it does. Sometimes you guys are in here and then I'll leave and I'll come back and be like, oh my God, it's disgusting in here. It's so hot and gross. But why? Why is it hot in here? But then if I walk outside, it's not. Where is that? Oh, there's something. Say that again, Kendallin.
Body heat.
Body heat. Yes, okay. So we, living beings, warm-blooded, give off heat, correct? So when I hold my cold iced coffee, which I lost, oh, there it is. Oh, let me just get a sip. Okay, and I hold it with my hand. What's happening here?
Your body heat is going.
Some body heat is transferring there. Ah! I'm making my own drink warm. Gross. I don't want it to be warm. Also, I get it with extra ice, so it's still. Okay? So, body heat. So we're going to need to add that. What else in here is causing heat besides body heat? Amora. The lights. Yes, the lights are going to put off. But is there like a lot of sunlight? I mean, I guess there is a little bit coming through our windows, but majority of the heat is not coming from the sun in our classroom. So can you just adjust that in your model?
Yeah.
Do you have a pencil? No. There's one right here. Okay, he's going to adjust that in his model. So I would cross out the sun. Yep. And then where is the heat coming from in our right now for this experiment? If we were outside, you could have put sun. So I would just label it. You just have to label it. You don't have to draw it. So identify where's the heat coming from. We just gave you 2 examples. Oh, there you go. It's from Ben. There it is. Yeah. Body heat.
Breathing.
Oh, that looks so good.
Oh.
Do it.
I can do it without.
Oh, it's the eyebrow. There it is. He has the eyebrow and all. Yes. Thank God for Ben and his creativity. Okay. What else, though? We identified another heat source. Oh, light. We got to put that, too.
Breathing.
Excellent. Okay. Make sure you're finishing your numbers. Sorry, I lost track of my thought. We should be on our 3rd one. All right. Can you show us your second model?
Yeah.
Okay. Do you need help putting it on? I know it's kind of. We're very squished today. Okay.
Cross out the sun. Cross out the sun.
Okay, he's gonna cross out. He already adjusting this model. He's crossing out the sun. Whew.
Another human?
He's gonna draw another human. This one has hair, a lot of it. Okay. All right, but can you explain what's happening with this is the fancy cup. What's happening with our fancy cup?
Right here is the outer layer.
Yeah.
Inner layer.
Yeah.
All the heat's getting stuck inside, in between them.
Okay. Okay, so that outer layer, those 2 layers are kind of trapping them. Okay. And so what does that do then to the liquid on the inside?
Protecting it from the heat.
Protecting it from the heat.
There's ice still.
Okay, and that's why there's ice still in there. Okay. All right. This is a little bit different thought. Okay. Any questions for Ben? Can we give him a round of applause? Great job, Ben. Get your 2 pieces of candy. Excellent work. Okay. All right, where are we with our data? Let's go now. Let's look at our data because I need numbers. So I was doing Chloe and Ben's group here. What was your 5-minute regular cup?
4 for the regular cup.
4. And what was the fancy?
2.
2. Okay. And what about 10-minute?
8 for the regular cup.
8. Okay. And then what is fancy?
Still 2.
Still 2. Okay. Okay. Is it warmed up? Maybe you're not breathing as heavy on it. No, I'm just kidding. Okay, excellent. Let's we're going to have one more. Oh, I need to set my timer. Sorry, set a 5-minute timer. Okay, we have one more we're going to do, and then let's go back here. Sorry, I didn't set my timer. All right, so what conclusions can we draw from the temperature data? I know we still have one more to grab, but I want you to start thinking about looking at your data, which cup is going to be the better preference and why. So again, we want to go back to the white. We don't really know the full reason, right? Because this is just our initial kind of jumping in, right? We would kind of be talking more in depth about energy and why things are happening. But right now, what conclusions can you draw from the temperature? So talk about it as a group.
So 1 degrees. Regular is better.
Oh, your data is still pretty similar. What's your guys' data? What's happening with yours?
They're not telling us, so we're trying
So they're at. So this one's warming up. The regular cup is warming up, and the fancy cup is going down. Okay, why? So the regular cup it's getting warmer, right?
regular cup 10.
And then the fancy cup is getting colder. So why? So I want you to think about that.
Everybody change the 1s to 10s and the 2 to 11.
Where's our data? Let me see.
Wait, what's the data?
Okay, so it's getting cold. The regular cup got colder, but then started to stay the same. And then our fancy cup went really cold and got even colder. Okay, so why? What can we talk about? Why does this data look like this? Why is this one this way and this one that way? Be ready to share. Okay, what did we get here? Oh, I already know your data because you gave it to me. Okay, so what were we thinking then?
So I was
Why?
thinking like this regular cup, like when you said condensation, I thought immediately cloud, and then I was like, wait, what if it's like a cloud? Because like it's kind of like you could see water on the outside, like it's sort of like dripping out like a cloud would when it rains.
Okay.
So I was thinking like it could be getting all the cold, it could be taking all the cold out of here because it's pretty cold, you know.
So the cold that is inside the cup is moving to the outside,
Yes,
like a cloud. Okay. And so then the water on the inside is getting warmer. Okay. Any thoughts behind that? Anybody else? It's good. I mean, it's a good initial thought. I'm going to ask you to share that to the class. Okay, that's good. Anybody else? Any other thoughts? Not yet? Okay, I'm going to walk away. Maybe you'll discuss more when I walk away. What did we come up with here? What do we think? Why? Well, I can't hear you. Oh, Maura has a good explanation on her paper. Maura, can you explain it to me?
For the fancy cup, when we touch the fancy cup, it won't melt because the layers are thicker, but the ice will still melt slower because of the heat from the light.
Okay. And what about the other one?
For the regular cup, when you touch the cup, it will melt faster because it has thinner layers, also because the light shines on it.
Okay. So we're saying here, like, this one has thinner layers. When we touch it, it's going to warm up faster. Okay. Whereas this one has more layers and it's not going to warm up as fast. All right. Good explanation. And excellent that you wrote it down. Thank you. Okay. Let's share. Let's share out. I'm going to have Chloe share her thought because it was pretty interesting. So if I could have everybody listening. Okay, we're going to be wrapping this up right now and moving on. Okay, go ahead, Chloe.
I was thinking, like, when Lila was talking about, like, the condensation on the outside of the cup, I immediately thought cloud. And I was like, what do clouds do? They rain. And this is kind of what, and that's kind of what this is doing because it's all on the outside now and it's just dripping down like a cloud does. So I was thinking that it's extracting the coldness and it's going on the outside, like right here, making the condensation like a cloud. So yeah.
It's what?
So she's saying that the heat that's on the outside, or the cup, or the cold that's on the inside of the cup is coming out, which causes that condensation like a cloud would, right? And then like almost like precipitation, right? It's going to start to fall down. Okay, so that in essence the heat is going to the inside of the cup and the cold is coming to the outside. These are wonderful thoughts here, which would drive to our next lesson, which is excellent, Chloe. Yes?
So what she's basically saying is that the condensation is taking the heat with it, and as the condensation gets heavier, it starts to fall, making the heat go away like sweat.
Kind of. I mean, that's what she's saying, right? I'm not saying it's right or wrong, right? But these are our initial thoughts as to what might be happening as to why one cup is better than the other. Awesome. Take your last data, and then we are going to share that out and wrap it up for today. So take your last data. It's okay. You don't, yeah, they're starting to fall apart. Just try to hold it on there, and then it's fine. Okay. Okay, take your last numbers. Let me know when you have your numbers so I can grab them. So you have 8 for the regular cup. Make sure we're recording your last data. So you're starting to go up now, right, slowly, and then we're looking at the fancy cup. Okay, let me know what you guys, make sure you get your last set of data numbers on there. What are you at, 5? Okay. Is it 5? No.
No, we're leaving it in there for longer because I don't think
It didn't reset enough.
3, no, 2. No.
You have to take it out to look at it.
3? Yeah, 3, 4.
Which one are you going with, 3 or 4? Okay, so we are going to, as long as you have your data on here, we're going to stop right here for today with this. We will come back to it.
Are the body temperatures stayed the same?
They stayed, exactly the same.
The fancy one went to 11, but then it came back to 10.
Oh, interesting. Okay. All right, once your group is done, if I could have somebody take the cups outside and dump them in the drain for me. And then I would like you to grab your Percy Jackson book.